Today's topic is components of hydraulic system. The main parts or components of the hydraulic system are reservoir, pump, coupling, motor, oil level gauge, suction strainer, vent plug, pressure gauge, valves, manifold, piping, actuator, etc. The reservoir, it holds the oil. The oil is taken out using pumps through piping and different types of valves to the actuator. Finally, the oil come back to the reservoir for the second time use. The pump mainly driven by the electric motor. The electric motor transferred the power through the coupling and the pump pumped out the oil from the reservoir and delivers it to the actuator. The oil level gauge. The oil level gauge indicates the oil level in the reservoir. The suction strainer. Strainer means a filter. The suction strainer, a filter used in a suction pipe, is called the suction strainer. It is connected to the suction line of the pump and serves as a filter. The vane plug. Vane plug to vacuum the reservoir. It is used to vacuum the reservoir. It is used to flush out the oil if necessary. During the washing time of the reservoir, it is necessary. Pressure gauge. Pressure gauge is used to measure the pressure inside the pipeline. The measures the working pressure of the hydraulic power pack. There are different types of valves. Those are pressure control valve, direction control valve, and flow control valve. The main function of the pressure control valve is to maintain the pressure inside the pipeline. Due to the high pressure, the pipeline may be damaged. So, the main function of the pressure control valve is to control the pressure. The direction control valve. The main function of the direction control valve is to direct the fluid flow. For forward motion and reverse motion, we can use the direction control valve to control the flow. And the flow control valve. To increase the flow velocity, it is used the flow control valve. Manifold, it is not the compulsory part of the fluid power system, but it is also used. Manifold, the valves are mounted on the blocks having the internal oil passage and provision for the external piping. The piping from the piping is the main part of the fluid power system. The oils or fluids are delivered from the suction strainer to the actuator. The oil passage is called the piping. Hydraulic hose, pipes, tubes are used for this purpose. Hose means the flexible pipe. Where is the flexible pipe is necessary, we can use the hose pipe. The actuator, hydraulic cylinder or linear actuator, is the final element where the hydraulic oil pushes the piston and thereby moves the load. Hydraulic motor or rotor can be used to obtain the rotary motion of the fluid. There are two types of actuator. The one is the linear actuator and the other one is rotary actuator. If we require the to and fro motion, we'll use the hydraulic cylinder or linear actuator. If we need the rotary motion, then we'll use the hydraulic motor or rotor. The hydraulic pump. The main heart of the fluid power system is the hydraulic pump. A hydraulic pump is a mechanical device that converts the mechanical power into the hydraulic energy. It generates the flow and with enough power to overcome the pressure induced by the load. To get the displacement of the actuator piston, the fluid will force the piston and will get the displacement and hence will get the energy and also the power. Here the topic is the positive displacement pump. What do you mean by positive displacement pump? Positive displacement pump means when the liquid comes from the suction side of the pump gets fully transferred to the delivery side. is called the positive displacement pump. The common some hydraulic pumps are gear pump, vane pump, piston pump. The gear pump may be two types. One is external gear pump and other one is internal gear pump. So next topic, external gear pump. External gear pump means here two gears are used for gear pump. For external gear pump, both the gears are external teeth are provided and both the gears rotates in opposite direction. At first we read the construction here. The principle of operation of the gear pump lies in the meshing and rotating of two gears. One gear which is mostly driven by an electric motor, you see it is called the driver gear, and the other one, the meshing with the gear, is called the driven gear. These two gears are housed in a closely fitted housing. The two gears rotates in the opposite direction. The main working principle is here. When the gear's teeth are disengaging, the pressure at the suction side drops, and this makes the oil to be sucked into the pump. As the gear continue to rotate, the oil entrapped between the gear space of the wall and the housing is carried forward to the deliver at the discharge side. As the teeth of the driver and driven gear start meshing again, the pressure builds up or pressure increases. At that time, the discharge side, the oil is pushed out to the delivery end. The more is the number of teeth, the better will be the continuous delivery of the oil. If the number of teeth are less, then the fluid flow or delivery will be pulsating. There will be gap or not regular discharge will be getting. Then we need the large number of teeth to get the uniform delivery of the fluid. Now come to the internal gear pump. The main difference of the external gear pump and internal gear pump here, in case of external gear pump, we have used two external teeth gears, and in case of internal gear pump, we will use one internal teeth gear and other one the external teeth gear. And there are another difference is here that for external gear pump, both the gears rotate in opposite direction, and for internal gear pump, both the gears rotate at same directions. In the internal gear pump, an external gear is located inside the internal gear and meshes with it. This internal gear is connected to the prime mover. It means the internal gear teeth will rotates and the external gear is stationary. As this arrangement, both the gears rotates in same direction. As the gears mesh and separate, the oil fills the gear space and the moving the chamber is formed that takes the oil from suction side to the delivery side of the pump. Next come to the second pump, that is vane pump. The vane pumps, we have the cylindrical rotor with grooves or slot cut along the circumference of the house of the number of vanes. Just like a library, in a library we put the books in vertically. That's like there is a slot on the periphery of the rotor. The vanes have a loose fit inside the slot. Loose fit means it can be moved out. When the rotor rotates, due to centrifugal force, the vanes wants to come out externally. But total the system is houses inside a cam type house. The house wall will prevent the fully come out of the vane. The cartridge unit means the total rotor and the vanes are known as a cartridge unit. The cartridge units are the slint into the driving shaft. A cam ring is fitted inside the pumping chamber over the splint shaft. The design of the cam ring and the rotor does not allow the rotor slot to come out completely. Working principle. As the driving shaft rotates, the rotor slots tend to come out due to centrifugal action. The vanes are held in the space between the slot and the cam ring. When they are extended by centrifugal action, the oil or the liquid is held between the chamber formed in the vane and cam ring and the rotor walls. As the rotor continues to rotate around, the vanes sweep the fluid to the opposite side of the delivery side. Due to the reduction of the volume, here the volume is reduced due to the cam type shape. Due to the reduction of the volume, the pressure builds up at the delivery side and which will force the fluid to deliver. Next, last, this piston pump. There are two types of piston pump. One is radial piston pump and other one is axial piston pump. For radial means the pistons are situated as radial portion or on the circumference of a rotor, and there is a radial rotation motion. Or in case of axial piston pump, it means there is a to and fro motion of the piston. For radial piston pump, as far as the construction principle of radial piston pump, radial bores in which the pistons are accommodated replace the radial slots. There are two types of radial piston pump. The one is the rotating cam, and in other one the cam is stationary. In this case, the rotating cam pushes the radial piston. The cam is in the integral part of the driving shaft. As the shaft rotates, the cam also rotates. Here, the cam rotates, the pistons are stationary. The pistons are accommodated in the cylinder block, which will be stationary. The rotation of the cam pushes the piston to deliver the oil. This radial piston pump with rotating cam. But the second type, on the other hand, in certain design, the radial piston pump, the driving shaft transmits the rotation to the cylinder, where cylinder are rotates, they are placed on a block. The cylinder block rotates, so the cylinders also rotate. And the cam is made stationary. This is radial piston pump with rotating block. In both the cases, the principle of operation is same. The axial piston pump. These pistons are made in the line with the axis of the driving shaft, which is connected with a swash plate. Swash plate is nothing but it is an inclined plate. The inclination can be changed. The swash plate angular placement of the swash plate, which ensures that fluid in or fluid out. As the driving shaft rotates, the swash plate also rotates, making the piston to reciprocate and facilitate the intake of oil and the subsequent outward stroke delivery of the oil. When the swash plate is away from the block, the pistons are drawn out, and when the swash plate is towards the cylinder block, the piston will be moved in. A compensator arrangement which adjusts the swash plate angle to get the variable delivery of the fluid. The delivery will depend on the angular position of the swash plate. Actually, the variation in swash plate angle changes the flow rate of the oil. Thank you.